that under dead load we were 7.89 millimeters in deflection under dead at joint 5. We take that number and we add it to the live load number, which is 27.02, and we add those two numbers together, which gives us 35 something millimeters, and that's our total deflection for joint 5 under service dead plus service live. So our next question now is, what are the reactions at joint 1, 2, 3, and 4 under the load combination dead plus live plus wind? So now, instead of going over to your reaction tool that you're probably thinking of doing, you have to come back up here and change your load combinations over again. You have your load combinations up here. Now you can come back, click on your reaction tool, and you have your reactions listed down here. Now you can write them out like this, or if you want, and it's easier to see on paper, if you come over to numerical, and after you go there, you click on reactions. If you come up here, here's your reactions, and your X force and your Y force all listed, positive and negative, nice and neatly. So those are your answers for that. And now for question D, is this beam okay for the moment in part A? Right? Is beam A okay for the moment in part A? Well, you have to go in your book and you have to find out if beam A is okay under what its maximum moment is. So you already wrote down what the maximum moment was for beam A, and I believe it was 386. And then you take that and you go look in your book, your steel book, and you look under and see what the value was. And if it was greater, if in your book it said beam A, which was W410 by 67, it could hold 400 kilonewtons, then the beam's good enough, because the moment's only 386. But if it said that the beam could only hold 350 kilonewtons, well, then the beam wouldn't be okay. It would fail because it's being overloaded by 36 kilonewtons. And you do something similar for the last question, which is a W200 by 46 sufficient as a column against the factored load dead plus live plus wind? What this question is asking you for, it's asking for the actual force going through column B. In order to find that out, you go on this tool right here. It says actual force diagram. You click on it, and column B is right here. You right click on it until it goes red, go down to properties, and here it'll tell you that the compressive force, the actual compressive force going through it, is 278 kilonewtons. So now you would have to look up that column in your book again, find out its unsupported length as well, and base that off and find out what value comes up. And if the value said it can hold 300 kilonewtons, then the column is good because it's only taking 278. But if the column could only hold 250 kilonewtons, well, then it's going to fail, and because you'll still be 28 kilonewtons over. And that's the end of that.